Welcome to Study Loop.
In this problem, we're talking about the energy difference between an atom and an electron. And that might sound a little bit counterintuitive, but this is extremely important in chemistry because a chemist's goal is to understand the energy of a reaction. And this problem is going to incorporate different concepts like comparing solid versus gaseous metals and things like localized electron bonding and delocalized electrons. So for part A, the first thing that we need to do is find the energy of a single electron off the surface of silver, because we're told the energy of the atom. So we're going to do a little bit of dimensional analysis to figure that out. So we'll have 731 kilojoules per mole. We'll multiply that by the fact that there are 10 to the third joules in every 1 kilojoule. And then to cancel out that mole, in every 1 mole, we have 6.02 times 10 to the 23rd electrons. And that simplifies to roughly 1.21 times 10 to the negative 18th joules. Now, our goal is to compare that to the value we were given. And we know that 1.21 times 10 to the negative 18th joules is greater than 7.59 times 10 to the negative 19th joules, which was the energy for the atom off of the surface of silver. So what we can say is that finding an electron off the surface of the metal requires less energy. So to remove an electron off the surface of solid silver requires less energy than removing an atom. Now for part B, we're told to explain what we just found using our concept of bonding and localized and delocalized electron bonding. Now electrons in solid silver are held together less tightly than the electrons in gaseous silver. And that's because the electrons in the solid metal, the solid silver, are what we call delocalized. So the delocalized electrons in the metal silver is weaker than the localized electrons in the gaseous silver. So that's why we see removing an electron requires less energy than the atom or in gaseous silver. So I hope that this problem helped you understand how we can calculate the energy of removing an electron off of a surface and then comparing it with an energy we were given, and then using our knowledge of electron bonding, specifically delocalized and localized, to understand what we found and why it's true.